less than the mean, and second part will contain all the values more than the median value.
Okay, ma'am. Thank you.
Okay, fine. So may I proceed to the next slide?
And could you explain categorical data?
Sorry.
Please elaborate categorical data.
Categorical data means the data, generally categorical is a term. Further, we can divide categorical into the two parts, nominal and ordinal. Nominal data means where only identification or categorization is possible. Say, for example, if I say nationality of a person, so might be a person can be Indian, a person can be Australian, a person can be the American, anything. So that is the nationality, right? That means I am only categorizing the respondents on the basis of their nationality, but I cannot say that there is a particular order. I cannot say Indians are superior than Americans, or Americans are superior than Indians. So in that case, I cannot do such kind of comparison. Only categorization is possible. So I can say that is known as the nominal variable, right? Then further, ordinal, a step ahead. Ordinal will categorize your data, and also you can set some order there. So say, for example, if I'm saying on the basis of age, I'm saying that these are the young people, these are the middle-aged people, and these are the old people, right? So that means categorization is possible. I'm saying these are the young people. So might be I am having a perception that these people are belonging to age group of maybe from 18 to 25 or something like that. Right? So that is young. And also, if I want to arrange them, I can easily say I can arrange them either in the ascending order or in the descending order. So that way, this is known as the ordinal data. So categorical data can be ordinal or it can be nominal. Is it fine, ma'am?
Yes, ma'am. Thank you.
Okay. So I hope now I can proceed.
Yes, ma'am. Yes, ma'am.
Yeah, thank you so much, sir. Talking about the next descriptives or descriptive statistics, that is the measures of dispersion. Measures of dispersion will always help us to find the deviation in the data. What is the scatteredness in the data that you need to calculate using the various measures like standard deviation, variance, and range. I have taken only 3 here because when we will apply descriptive statistics using the Excel will provide us only these 3 things, right? Otherwise, there are some other dispersion methods also available in statistics, but mostly used are these 3, and Excel is giving the output of these 3. Right? So the purpose of finding the deviation is that it is quite obvious. Suppose I am having, say for example, if I have taken a quiz in my class, I am a academician, I have taken a quiz in my class. So in that case, whatever are the scores coming, I want to get the average of that. I think it is quite easier for me. I will sum all the scores, and then I will divide that sum by total number of scores. That way I will get an average. But it is quite obvious that whatever is the average value, all the observations or all the scores will not be similar. That means there would be some discrepancy, there would be some differences in the scores and the mean figure, right? So that way I need to see that deviation. And for checking that deviation, we are using standard deviation, variance, and range kind of measures to find the deviation in the data. Is it okay?
Yes, ma'am.
Yeah. Thank you. Talking about the measures of distribution, as I said, we need to know whether the data is normally distributed, because when we are talking about statistics and when we are talking about parametric tests like t-test, z-test, or correlation regression further, you need to always check whether your data is normally distributed or not. And for checking this thing, you need to check skewness value and the kurtosis value. So skewness, generally, we all know that the normal distribution is nothing, but it is shown by this particular bell-shaped curve. I hope you would be able to see a graph, the very first graph at the extreme right side column. You can see this is the first graph. This graph is the normal distribution curve, right? So that means looking at this graph, we can understand the skewness, right? So I can say skewness is what? Skewness is the measure of asymmetry in the data, whether your data points are equally distributed both the sides of your mean or not. Because as per the characteristics of normal distribution, we know that the mean lies at the middle. Means if I will draw a line here, I can say this would be the mean of the normal distribution or of the data. For that we have shown or we have drawn this particular normal distribution curve. So this middle line will indicate as the mean figure, right? So if 50% of the data is lying at the left hand side of the mean and 50% of the data lying at the right hand side of the mean, in that case we can say there is no skewness, right? Your data is totally skewness free, or there is no asymmetry in the data. Your data is symmetrical to mean, right? I can say if this is the mean figure, so that means 50% will fall at the right hand side, 50% fall at the left hand side. So that means if I will fold this curve, so both the sides will be overlapping to each other. Is it clear? That is known as the study of the skewness in the data, right? But if your data proportion of the data is not same, means 50% is lying at the left, 50% right, lying at the right. If this proportion is changes, right, might be possible 70% is lying at the right and 30% is lying at the left. Any proportion can be possible, right? That way, this is known as the your data is skewed data. In that way, you can see the remaining two graphs. From the tails, we can understand this thing. The second graph is telling us that the right tail of this graph is greater than to the left tail, and the third graph is telling us that the left tail of the graph is greater than to the right tail, right? So that way your second and third graph is showing your data is skewed data. Second graph is showing your data is rightly skewed because here the right tail is greater than to the left tail, right? This is the bigger tail. The right tail is the bigger tail. We can call it as a rightly skewed data or positively skewed data. When your left tail is taller in comparison to the right, you can call this data as a left skewed data or negatively skewed data. Fine. So this is the study of the symmetry or asymmetry in the data using the skewness. For the perfect normal distribution, the skewness figure should be 0, right? But if your skewness value is coming positive, you can call your data is positively skewed. If your skewness value is coming negative, you can call your data is negatively skewed. Fine. May I proceed with the next slide?
Yes, ma'am. Yes, ma'am.
Yes.
Talking about the next measure under the distribution is the kurtosis. Kurtosis is the study of the peakness and the tails of this curve. Means what is the tail? Means whether the tails are thicker or whether the tails are thinner. That you need to see, right? So the very first graph is telling us this is the perfect normal distribution curve. No thickness, nothing, everything is in proportion. We can call the kurtosis is 0 for this particular graph. But as we proceed, you can see in the second and in the third graph, second graph is indicating you that the peak, this peak means this particular shape, if I say, so the peak of this is very sharp. This peak is very sharp in comparison to the previous one, right? And when we will talk about the tails, so tails are heavier. That means these are the thick tails. So that way you can say that your data is the positively skewed data, right? Talking about the next, it is telling you this this graph will be little flatter. The red or dotted graph you need to see here. This is the shorter peak, and the thick these tails are the thicker. That means I can say this thing. This type of kurtosis coming or the kurtosis value will be negative. I think these are the measures, and these value we can calculate. Formula is available in statistics. But when we talk about the softwares will give us these values, right? So positive value of kurtosis will tell us that your data is leptokurtic data, and negative value of your kurtosis will tell you that data is platykurtic. Sorry. So now again I'm coming back, and I was talking about the kurtosis. As I said, kurtosis is the study of the peakness and the tails, whether the tails are thicker or thinner, right? So if proportion is very correct, like the first graph, we can say the kurtosis is 0 and your data is normally distributed. But when the peak is sharp, that is the second graph you can see. So in that case, you can see the tails are thinner, and in that way we can say that the kurtosis value will be positive for us. We can say this is the positively kurtotic data, or the technical name is the leptokurtic data, right? When the peak is shorter, that is flatter peak, right? And these tails are thicker. In that case, we will get the negative kurtosis value. And we can say this thing that the data is platykurtic. So platykurtic is the technical term for the kurtosis, right? So 0 means mesokurtic, positive means leptokurtic, negative means platykurtic data, right? So using this, we can understand whether the data is normally distributed or not. So these two measures, that is the skewness and kurtosis, these both will help us to understand the normality of the data. And in the case of statistical tests like T and Z, because for all the statistical tests there are certain assumptions available, and among all the assumptions, the normality assumption is the very important one that we need to generally check. So using these figures, we can conclude about the normality of the data. I think it is about the kurtosis slide. Is it fine? May I proceed?
Yes, ma'am.
Yes, ma'am.
Thank you. Talking about standard error of mean. So standard error of mean is nothing but it is the standard deviation of the sampling distribution of the mean. So I think it is little technical to understand, but again, but I'll try to explain you this thing. What is the meaning of this? So say for example, there is any population available. From that population, we are drawing the samples of the similar sizes. Say for example, the size of population is 1 lakh, right? And I'm drawing the samples of 50-50 size, right? So that way, suppose I'm drawing so many samples of 50 size 50 from that particular population, and for each sample I can calculate the mean. So that is sampling distribution of mean, and then of that distribution you need to take the standard deviation. This is known as the standard error of mean. I hope I have explained you this thing, and I think successfully I have explained this. Is it okay? Clear? Little trickier?
Can you please repeat it, ma'am? Just whatever you have explained, can you please just repeat it?
Just a minute. I think rather than doing this, give me a second about what I'm doing. Yeah. As I said, suppose, just a minute. Suppose, I hope you can see my
Yes, ma'am.
Word file, right?
Yes.
Yeah. I have written here the population size. It is 1 lakh, right? Now I want to draw a sample. So size of sample is suppose 50. Is it fine?
Yes, ma'am.
This is the first sample I'm talking about. But from this population, I can draw some more samples also, right? So for each sample, I can calculate mean. So suppose I have calculated mean. So it would be for first sample, suppose mean 1. Next sample, it would be mean 2, and likewise, right? So coming down, I can say, and lastly, suppose I have written mean 20. Is it fine? Suppose I have drawn 20 samples from the same population. For each sample, I calculated mean. I think it is not tough to calculate, right? Ma'am, is it fine?
Yes, ma'am.
Yeah. So what I said, now this will become a series of means. So it would be the sampling distribution of mean. And when I will calculate the standard deviation of this series, this is known as sampling error of mean. Now, okay, ma'am, clear?
Yes, ma'am.
Yes, ma'am.
Yeah. Yeah. So coming back again, yeah. Usually, as you can see in the name itself, the term is coming error. Error is always a bad thing. It is quite obvious, right? So when I talk about statistics, so generally if error term is coming, that means it should be very less value, a very smaller figure in terms of magnitude. But the problem with the case of standard error of mean is that there is no threshold value available. If I say skewness, we know skewness should be 0 for normal distribution, but we don't know what is the threshold value for the standard error of mean. right? We only know this thing, it should be very minimum. This is what we can say, right? Smaller standard error indicates that the sample provides you the precise estimate. This is what we can say. So error should be very small, but there is no threshold value from that I can compare and say this is if this value is coming is this, it is fine with me. It is not like that. Is it okay? Is it fine? I'm not getting. Is it okay?
Yes,
Yeah,
ma'am.
yes, ma'am.
Yeah. Further, I'm going ahead and talking about the confidence interval of the mean. So as we have seen, standard error of mean is the statistics which is telling us the value should be very small, but it is not telling us what the value should be, right? So to overcome this thing, we are having the next thing, that is the confidence interval of mean. So this particular confidence interval meaning that is a range, right? So when we are having a range, so that a range is saying us that the population mean will fall in that particular range. So I hope you people will be able to connect with me, because why I am discussing or saying all these things, because we all know in practical life we cannot cover or reach to each and every unit of the population, right? We know the size of population is very large. So for the purpose we are taking a small sample, right? So that is why we need to ascertain this thing, that whether the confidence interval, whatever is coming, will include your population mean or not. So that means standard error of mean should be smaller, but using the confidence interval of mean, somewhere we can conclude that this particular range will include the population mean. Fine. So that means this particular, as you can see, standard error of mean, if I say, this standard error of mean will help you to calculate your confidence interval of mean. So that is why there is an importance of standard error of mean. Fine. I think it is little technical. Is it okay or no?
Ma'am, can you repeat once?
From?
Ma'am, what is actually the confidence interval is, and what consequences?
I said confidence interval of mean is nothing. It is a range. Say for example, upper limit and lower limit. That is a range, right? Similarly, confidence interval of mean is also a range, and that range generally ascertain as this thing, that your population mean will fall in this particular range.
Okay, ma'am.
Yeah.
How can we define this
Ma'am,
range?
this-
Can you give me example of it?
I think, ma'am, this is all output we will get there in the Excel. All the outputs we will apply through the Excel, and we will get everything there. So there I'll explain you these things.
Ma'am,
Fine.
this confidence interval is 5%, 95%.
That is
It is the
confidence level. No, ma'am, that is confidence level. It is not confidence interval. That is confidence level.
okay.
Interval is the range, right?
So, ma'am,
Simple, it
so-
is range.
Yeah. It's a range. That is confidence level 95%. The level of significance and confidence level, those two
So how
things
do we get the range, ma'am? How do we know which range is the value?
Ma'am, this range will given by the softwares. You do not need to calculate this. This will be given
Okay.
by the softwares for us. So in each of the output, we will see this thing. Today also, when I'll explain the descriptive statistics using Excel, there also we will get this range.
Okay, ma'am. Thank you.
Okay. Yeah, fine, ma'am. Thank you. So this generally, which particular means this range should be narrow. Narrow range indicates that your estimates are precise estimates. Means you would be able to precisely estimate your population mean. So generally, this range should be a smaller range, or the difference in the range is very small. This is the crux about the confidence interval of mean. Now, if you want to perform descriptive statistics using Excel, so firstly, you need to add in the data analysis toolpath in Excel. Might be possible many of you are having this particular thing added on. If not, I'll let you know how you can do that, right? So I think this is, I can escape. I'll go to the Excel now. I hope you people all have downloaded a file I have already shared on the group. Yes? On WhatsApp, I have shared a sheet with the name Demo Descriptive Statistics. I hope you people have found it. Please give me a confirmation. I think this is Excel class, so nobody can make an excuse that you didn't perform. Sorry. I hope you all have got that, right?
No, ma'am. I am not in a WhatsApp group.
Okay, so in that case, I think a member of RFI can help us in that. Yogi sir, are you there? So can you share a link of WhatsApp here? Yes, sir. Please, can you share in the chat box? Yeah, thank you so much, sir. Yes, I think group chat WhatsApp link is available there in the chat. So I hope you people can please access the link to join the WhatsApp group. Everyone, please do it. Right? You people have joined the WhatsApp group.
I request the organizers to please forward the link
Yes,
again
yes,
to
ma'am.
WhatsApp group. Yes, it is not there.
I think in chat the link is available, Nidhi ma'am. Are you talking about chat box?
To WhatsApp group.
Okay.
Can't open them.
So I think, give me a second. Yogi sir has shared the sheets also there on WhatsApp group. I hope you people have got the sheet. May I start explaining?
Yeah, got it, madam.
Yeah. Yes, ma'am.
So can I start explaining now?
Yes, ma'am.
Okay, fine. Yeah. So now coming back to the Excel demo sheet, I think you would be able to see this kind of sheet there, right? And here you can see we are having two variables available, height and the weight, right? Now, firstly, I'll let you know if I want to find all the things using the functions. I think you all know there are functions, inbuilt functions available in SPSS, right? So in hurry, in fast term, I'm writing here a few things. That is the mean, median, mode, standard deviation, variance, skewness, kurtosis, min. I think I expect all of you to perform along with me, right? Now, to find the mean, you need to type average. And here you need to give the range of your variable, that is height variable we are talking about. So I selected the observations for the height variable under the average function, closing the bracket, pressing enter. So average height is 1.51, right? Similarly, for median, you need to put a equal sign. Please do not forget to put a equal sign. Put a equal sign and then write a function name median. In a bracket, you need to give the range of your data. So you need to select the range, you need to close the bracket, need to press the enter. So the median height is 1.5. Putting equal, writing the mode, and then selecting the data, closing the bracket, and then pressing enter. So the mode is coming as 1.4732. Standard deviation, put a equal, type STDEV, open a bracket, give a range, close the bracket, press enter. Variance, put equal, write type WAR, open a bracket, select the range of a variable, close the bracket, press the enter. This is the variance. Now, skewness, put equal, now type SKEW, that is skew, and then select the range, close the bracket, and press enter. This is skewness. Kurtosis, KURT, open a bracket, give the range, close the bracket, and press enter. Equal, use min function, give the range, close the bracket, press the enter. Right? Now, here I am. Next. So this is all the statistics, descriptive statistics we can also calculate using the functions, or the second way I will explain you after this. I hope you people have able to cope up with me. People have people are able to find all these things easily, right? No problem with that. For mean, average function, median function, mode function, standard deviation, STDEV function, variance, VAR function, skewness, SKE.
Ma'am, excuse me, ma'am.
Yeah.
From where we have got all these values, I mean for the mean, median, mode, then standard deviation, skewness, from where we have got all these values, ma'am?
We have given a range of the data.
Okay, ma'am. Thank you.
Okay, fine.
Range.
I hope it is okay with all of you.
Yes,
Um,
ma'am, yes.
Explain the command for minimum and maxima.
It's min and max only, sir.
Okay, ma'am. Okay, ma'am.
This min.
Ma'am, please repeat for median and mode.
Same, ma'am, with the name only, the function is there.
All right, thank you.
Okay. So this is about the statistics using various functions. I think someone has forgotten to close the mic. Yes. Now you need to see how we can perform descriptive statistics using the data analysis toolpack. For that, I'll explain you how to add it. So you need to go to the file menu. I think first you need to see the steps. You can please see on the screen and check what I'm doing here. Click on the file. Here you need to go to the options. Here you need to select add-ins. And then here go down under the manage Excel add-ins, click on the go button. And here you need to select the analysis toolpack. This checkbox you need to check. And then you need to press on OK. This is the process of adding the data analysis toolpack in your Excel file. Is it fine? Process is clear to everyone? File, options, add-ins, go, check the analysis toolpack and press OK. Is it fine?
Can you say once again, ma'am?
Sorry?
This? Can you once again explain this?
Okay. Go to the file, select options, select add-ins, then click on go, then select analysis toolpack and then press OK. That's all.
Thank you, ma'am.
Okay, fine. After adding it, I haven't pressed on OK because it is already added in my Excel sheet, right? So now where you can find it under the data tab or data menu, right? You can click on the data and you can see extreme right. This is the data analysis toolpack, right? Is it okay?
Yes.
Yes. Now you need to click on the data analysis. Once you will click on this, by default, you can see the descriptive statistics option is selected here, right? So you need to only click on the OK button. I hope you all are able to cope up with me. May I click on OK? You people have found it?
Yes, ma'am.
Okay, fine. Thank you. Great. Click on the OK button here to see the dialog box of descriptive statistics. I hope it is visible. May I start explaining this? Give me
Yes,
a
ma'am.
everyone.
Yes.
Okay. Now what you need to do? In the first section, it is asking us to give the range of a variable. For that, we want to perform or get the descriptive statistics, right? So here you can see the cursor is blinking in this box. So here you need to select your data. You need to pay attention on my screen. I am selecting the data, including the label of my column, right? So I selected my data, including the label. Done? I hope it is done, right? May
Yes,
I?
ma'am.
Right. Now the second section is asking us grouped by. So Excel is asking us the data is grouped by column or row. So I think it is quite visible to everyone that data is in the column. So our data is grouped by column only. So we will go with the by default option. But if data would be in a row, in a horizontal form, in that case, you will click on the rows. Fine.
Yes,
Okay,
ma'am.
ma'am.
Now, next is labels in the first row. So as I said, I have selected my data including this label, that is height. You can see here, my data is selected starting from the A1. And in A1, height is there, right? So I'm selecting this checkbox that labels in the first row. That way, Excel will understand that this is the text and this should not be included. And it is quite obvious. The numbers and words together, average and everything cannot be possible to calculate. So that is why we need to give the instruction that labels there in the first row. Fine.
Yes, ma'am.
Next section is asking us about the output options. So here we are having three things. First one, output range. That means if you want to get your output in the same worksheet in which you are working, from which we are taking the data, you will go with the first option. Second is new worksheet. So if you want to generate your output in the new worksheet, you will go with the second option. Third is saying new workbook. If you want to get your output all together in a new workbook, you can go with this option also. But usually I always go with my first option, that is output range. And after that, you need to click the mouse in the box, right? Or else this particular range will change then, right? So you need to select first option and you need to click your cursor, or you need to put your cursor in this particular box, right? And here you need to give a reference of a blank cell. Suppose any of the cell where there is no data available. So here I have given the reference of a blank cell. And then moving ahead to the next section. I think it is okay. May I proceed?
Yes, yes, ma'am.
Then first is summary statistics. Yes, we want to calculate. You need to check this box. Then 95% level of mean, it will give us the 95% confidence level of mean. If you want to get that, you can click on this. Further, kth largest. So here it is by default 1. So it will give you first largest figure. Kth smallest, by default it will give you first smallest value if you're checking these boxes. You can see if I'm clicking on this way, this particular box from the gray color, it is now turned into the white color. That means it is ready to accept the figures, right? So if you want to check, suppose fifth largest or 10th largest, anything. So that way you can come here and you can type from your keyboard whatever value you want. But I think we do not need these things. So I'm not checking this particular box. Except this, I have only checked this. Except all this, we are going with the only first option, summary statistics, right? And then you need to press on OK. So I think I'm all set to generate the output. Now you need to give me a nod. May I proceed?
Yes, ma'am.
Okay. Yeah, so in a second, you can see whatever exercises we have done manually, we are getting everything here, right? You can see the mean is almost same, 1.508. So that means it is approximate 1.51. Standard error of mean is 0.007. Median is 1.498. Mode is 1.4732. Standard deviation is 0.0733. Variance is 0.00537. Kurtosis is -34. 565, skewness is 0.11495, range is 3302. So range, how come this range value came? So this is the difference of maximum and minimum, right? So maximum minus minimum will give you range. So you can see this way we are getting the range. And then total of the height is 132.74. Total counts are 88. Total 88 observations are there. So this way, we can find the descriptive statistics using Excel. So I think I have shown you both the ways, using the data analysis tool pack and using the functions. Is it okay? Clear to all? Now you fine?
Yeah, it's fine, ma'am.
Okay. So may I proceed to the next topic of the day?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. So now, give me a second. I'm coming to here. Now we will talk about I-square test. Give me a second. I'm increasing the font size. Visible to everyone?
Yeah,
Yes,
yes.
madam. Yes, madam.
Yes. Now we are discussing the next agenda or next topic of our day, that is the chi-square test. So chi-square test is generally a non-parametric test. This is a non-parametric test. That means this test is not bothering about the normal distribution of the data. No consideration for the normal distribution of the data. So that is known as the non-parametric test. That means these are not based on the parameters of population, right? So that way we can say there is no consideration for the normal distribution of the data. Apart from that, these type of tests are based on the categorical data. Categorical data means nominal data or ordinal data, right? Now, talking about chi-square test, I can say there are two types of chi-square test. The first one is known as goodness of fit test, and the second one is known as independence of attributes or independence of association, right? So this way there are these two types of chi-square test available. In case of goodness of fit, we need to have only one categorical variable. But in case of independence of attributes, we need to have two categorical variables. Right? So, if I talk about goodness of fit, so what goodness of fit does? It checks the uniform distribution of frequencies. Now, as I said, we are talking about the non-parametric test. So here, chi-square test deals with the frequencies rather than there are no values or something. Here we are having the counts or frequencies. So counts and frequencies are one of the same thing, right? Say for example, how many of the students are liking this subject? How many of the students are not liking this subject? So that way I am getting the count or the frequencies, right? So that way I need to check whether the frequencies are equally distributed along all the categories of the categorical variable or not, right? Say for example, if I am taking the color preference of the students, suppose I have listed black, white, blue, and red. Suppose these four colors I have listed and I'm asking from the students, please give your preference, right? So suppose in my class there are 60 students. So suppose 23 are saying they are liking the black color. Suppose 15 are saying they are liking the might be white color. And then 10 are saying they are liking the blue color, and suppose 12 are saying they are liking the red color, right? So here we want to see these are the frequencies How many time or how many of the students are saying they are liking black? How many of the students are saying they are like white color? So that way I have counted them. So these are the counts of frequencies available with me. Now here we are looking whether these frequencies are equally distributed or not. So here we can see 23, 15, 10 and 12. But we need to check whether these frequencies are significantly equally distributed among all the categories of color or not. So that way we are going for the goodness of it. Wherever we want to see the uniform distribution of the frequencies throughout all the categories of a categorical variable, this is the case of goodness of fit, right? So in such case, how we will formulate our hypothesis? So our hypothesis will be there is no significant difference in the observed and expected frequencies. This would be the null hypothesis, right? Alternatively, I'm copying this to save our time, and alternatively, I'm writing there is a significant difference and H0 is converted to H1. So H0 is the null, H1 is the alternative hypothesis. So this way I have formulated the hypothesis for goodness of fit. Here we are having a single variable, and for that single variable we are looking for the we are looking for whether the expected and the observed frequencies are similar or not. So here you can see these would be your observed frequencies, because I have observed in my class how many of the students are liking black, white, red or any other color. That way I have listed down the frequencies. Now I'm expecting these count should be equal throughout the categories, right? So that means the expected count should be same throughout the categories. And that way again comparing the observed and expected frequency. So this would be the goodness of fit. Is it fine? Goodness of fit.
What is the difference between alternate hypothesis and this null hypothesis?
I think from reading a statement, you can understand the difference. Please mute yourself firstly.
Okay.
Yeah, because I can hear my voice twice, right? So now here the difference is very clear when you are reading the hypothesis. First is saying there is no significant difference, means observed and expected count is same. This is the meaning. But alternatively, I'm saying there is a there is a significant difference, means observed and expected count is not same. The difference is existing, right? Fine, ma'am?
Yes, ma'am. Yes.
Yes.
Thank you.
Ma'am, I have a question.
Yes.
Ma'am, how much difference we shall be considering as a significant or non-significant?
I think we do not need to do that, ma'am. Using the p-value, p-value is sufficient to say that thing whether the difference is significant or not. Looking at the p-value, I think when we are going to the Excel, and there I'll explain you. The results will come, and looking at the results, we can conclude the difference is significant or not, because we cannot decide upon whether this difference is significant or not. On the basis of the probability value, we will say whether the difference is significant or not, right?
Okay, ma'am. Thank you.
Now further, there is one more terms come, that is the degrees of freedom. The formula in case of goodness of fit for the degrees of freedom is n-1, right? So total number of categories minus 1 will give you the count of degrees of freedom. Means this is the freedom degree, that how much should be the categories can be free. That is the degrees of freedom. Now, talking about the second statistical second category of the Pasteur test, that is the independence of attributes, right? So independence of attributes means here you will having the two variables. So two variables will be categorical, and using those two variables, what you need to do, you need to prepare a contingency table, right? Say for example, I'm having here the one variable as male, second variable as female. I'm asking whether you people are liking statistics or not. So answer can be yes or no. So suppose in my data there are 100 male and 100 female, right? So out of 100, suppose 32 are saying they are liking statistics, and suppose 68 are saying they are not liking statistics. Now female out of this, suppose 43 females are saying they are liking and 57 are saying they are not liking it, right? So that way in yes category, if I want to calculate, so there are total 75 people, and here also we are having 125 people, and total is 200, right? So this would be the total row wise and column wise. This way we are preparing the contingency table, right? So this would be your row total and this would be your column total. For yes category 75 out of 200 and 125 for no category out of 200. For male category 632 are saying yes and 68 are saying no. Out of 100, 43 of the women are saying they are lacking statistics and 57 are saying they are not lacking statistics, right? So here we want to say, because I'm talking about what? I'm talking about the independence of attributes, right? So these are the attributes. The attributes means gender is attributes. Yes and no liking of the for the subject is again an attribute. So I want to see whether these two attributes are independent to each other or not, right? So in that way, I can formulate my hypothesis like there is no association between liking for statistics subject and gender. This can be the one way of formulating your hypothesis. Other way around, you can say null hypothesis can be that the liking for statistics subject is independent of gender, right? Hypotheses are clear?
Yes, ma'am.
Ma'am, why association in place of difference here?
Ma'am, if you want to write, you can write reference also, but here the name itself is the independence of attributes, whether the attributes are independent to each other or not, whether they are independent or dependent, means related. Related meaning is association.
Okay.
Okay. So is it fine?
Madam, is it HO and H1, the second?
So this is HO. I think I have told you in two ways you can formulate your null hypothesis.
Okay.
Right?
Okay,
Alternatively,
okay.
you can copy this and you can write there is
Yeah,
an association.
Uh,
Okay. Is it fine, sir? May I proceed?
yeah, can proceed, please. Thank
Yeah.
you.
Now, most welcome, sir. Now the degrees of freedom in case of independence of attributes is R minus 1 into C minus 1. That is number of rows minus 1, number of column minus 1 will give us the degrees of freedom. These all are generally we are using for the manual calculation purpose. I don't know how many of you are knowing the formula of chi-square test. Can anyone tell me? Anyone who is knowing the formula? I have copied down the formula for all of you here. You can see this is the formula of chi-square test for the manual calculation, which says chi-square is summation of O minus E square divided by E, where O is the observed frequency, E is the expected frequency, right? But how we can calculate expected frequency? Because observed we will be having, we will collect the data for observed, but expected, so you need to check. I think we will go to this sheet and I'll tell you there. So I'm expecting every one of you to download the second sheet with the name demo chi-square. Downloaded? Give me confirmation, please. If people have downloaded it.
Yes, ma'am.
Okay, fine. So in this particular sheet, I have given you a very simple situation. Here we are talking about a table in which we are having the number of students, pupils, those who were the absent on a particular day. Here you can see Monday, Tuesday, Wednesday, Thursday, and Friday, right? Numbers is written here that on Monday total 125 students were absent. Similarly, Tuesday to 88, Wednesday 85, Thursday 94, Friday 108, right? Now these are the observed count or observed frequencies. Now you need to calculate expected. So as we can see, we are having a single variable day, and in this day we are having 5 different days available. So this is very simple to understand that this is a case of goodness of fit, right? Now, in case of goodness of fit, your expected frequency will be nothing but will be the average of observed frequency. Hello? But I hello. Sorry, it was a urgent call to take me. Sorry. So I have taken that call. Extremely sorry for that. Now I was talking about expected frequency. So expected frequency we can calculate using the average of observed frequency. I think it is very simple to calculate average, right? You can select these observations here, right? Once you are selecting these observation, that is the observed frequencies. I think here in the just a minute. So here in this particular Excel file at the bottom, you can see it is showing us the average also. Average is 100, count is 5, sum is 500. Or else, what you can do, you can come and write here the function average. And you can select the range and you can close the bracket and press enter. It is again giving you the 100, right? So now nothing you need to do. You need to only type here 100 throughout the column. For all the categories, sorry, for all the categories, the expected count will be 100 or expected frequency will be 100. I hope it is clear. No doubt.
Yes, ma'am.
Now, just a minute. Yeah, I have shared my screen. I think it is visible, right? May I start explaining?
Yes, ma'am. Please go on.
Yeah.
Yes, ma'am.
Now you can see here we are having the expected frequency. Here we are having the observed frequency. And I have given you three functions here. The first function, that is chi-square dot test. This will give you the p-value. The second, chi-square dot inv. This will give you the critical value. Critical value means the table value of the chi-square. And then calculator value of chi-square will be found using the chi-square dot inv dot rt function. Using these three functions, we can get these three values, right? Now, what is the importance of these all? We will get one by one. First, I'll tell you the first thing, that is the put a equal sign, right? CHISQ dot test. This can be without dot also. Is means according to the versions, maybe it can be different also. So CHISQ dot test can be, or CHISQ test also is fine, right? And that way you can see once you have typed it, and then in the brackets it is asking you to give the range, actual range and expected range. Actual range meaning is observed frequency. So you can select the observed frequency range, put a comma, and select the expected frequency range and close the bracket. This is what you need to do. Is it fine?
Yes, ma'am.
Then you can press enter. So that way we are getting here the p-value. The p-value is 0.027. So suppose we want to test our hypothesis at 5% level of significance. So the level of significance is suppose 5% and p-value is coming as 0.027. So always there is a thumb rule if you want to take a decision whether the difference is significant or not in the frequency. So thumb rule says is if p is greater than p is less than 0.05, we are going to reject the null hypothesis. If p is greater than 0.05, we are going to accept the null hypothesis. This is the thumb rule, right? So here, if we want to say for our data, we can say this is less than 0.05, right? Our p-value is less than 0.05, and if it is less than 0.05, that means we are going to reject the null hypothesis. That way, we can say that these frequencies are not same. There is a significant difference in the observed and expected frequencies for the absentees, right? Is it clear?
Yes.
Yes, ma'am.
Yes, ma'am.
Fine. Now talking about the next thing, talking about the critical value, that is the table value. So I think you people are knowing when softwares were not there for getting easily the p-value. So using the tables, we can easily get, or we can easily compare the values and can make a decision whether we are accepting or rejecting the hypothesis. So as we are learning all these things through the Excel, so we will not go in the manual calculation for calculating the calculated value of the chi-square. And here we will directly find that calculated value using the function. So here you need to type CHISQ.INV.RT, right? And then this is the third function. You can see it is asking us the p-value. So p-value we have just calculated, that you need to select, put a comma. Degrees of freedom will be 1, 2, 3, 4, 5. 5 minus 1, that is 4, right? N minus 1 will be the degrees of freedom. So total are 5 categories we are having. So 5 minus 1 is 4. And when you can press in enter, you will able to get the chi-square calculated figure. Fine. Is it okay?
Yes, ma'am.
Now chi-square calculated or tabulated, critical or tabulated, if you want to get, you can put a equal sign. You can type CHISQ.INV. And here you need to pass the confidence level. If level of significance is 5%, confidence level will be 95%, right? So here I'm writing 0.95, comma, then the degrees of freedom is 4 and bracket close. Fine. Pressing enter. So this is giving me the table value of the, or critical value of the chi. So on the basis of this, the thumb rule is different. Thumb rule says if your calculated value is less than critical or table value, in that case you will accept your null hypothesis. Vice versa, when your calculated value is greater than your critical value, you are going to reject the null hypothesis. Done? Now you can see, if we will look at our data, we can say our calculated value is greater than to the critical value. So that means we are going to reject the null hypothesis. So either we are summarizing or concluding with the p-value, or using this calculated and critical value. In both the cases, answers will be same. There is no difference, right? Fine. Is it clear to everyone?
Okay, ma'am.
So this is about the chi-square goodness of fit. Next sheet which I have given you, that is for your practice purpose. I am directly coming to the third sheet, demo IOA, independence of attributes. So I think everything is solved here. I forgot to remove the things, right? So I think it will save our time. You people can see calculations there. I'm explaining you the thing here, right? So here we are having two things. We are having the wealth or wealth status. That is the, we are having three wealth status: middle, poor, and wealthy people, right? and we are having the graduation level, yes and no, whether the person is graduated or not. So that we are having here, right? What I did here, I have in this particular, I have with this particular data, I created here the contingency table, right? You can see one variable of categorical, or one categorical variable I have taken in the row, that is wealthy, middle and poor. So 3 categories I have written here, and 2 categories of the next variable I have written in the column. Then now what I did, I came here and I have used the filter option, and that using that, suppose I am clicking on the wealthy, pressing on OK, and then I am selecting here only the yes. So how many of the wealthy people? Those who are graduated, right? You can see the count is coming as 6. Right, you can see the count is 6. So you can find I have written here 6. So that way, using this filter option, I calculated the frequencies easily for yes no category, along with this wealthy, middle and poor status of the wealth. And that way you can sum this using the sum function, or in here you can see the sum was very simpler for me to calculate. So I have easily done the calculation, and I have put the total in the row, similarly in the column. So that way we got the row total and column total. I think this table is now simpler to understand, right?
Yes, yes, ma'am.
Now coming to the next table, here what you need to do, here you need to create a contingency table for the expected frequency. This is what the, based on your data, that is observed frequency. Now we are using the next table for the expected frequency, right? So I'm writing here the formula for all of you. I don't know that formula is there or not. If not, you can note down. The expected frequency EF can be calculated as row total into column total divided by grand total. This is the formula, right? So for example, firstly you need to see what I'm saying here and what I'm applying here. You need to see all the formula already applied there in your sheets also, but how I have done that, you need to understand that. Suppose I want to calculate the expected frequency in case of wealthy and yes, this category, right? You can see here what I did. I came here for this wealthy, the total is 11, and for this yes, total is 20. So this is row total, this is column totals, that is 11 into 20 divided by 38, that is the grand total. So this is what you can see, this function, this particular cell references you can find. Once I'm clicking on this, you would be able to see the selections, right? Color you can easily find here. Clear?
No value, could you tell me, madam?
Sorry?
No value. No value, no value. Here, wealthy, middle, poor total is there, na, madam? This graduation level table. Contingent table, observed frequency. Here, no is there, na, madam? No, 5.
This?
This left side. 5.
Yes.
Yeah, 5. Yes. How we
Yes.
got, madam? How we got that one?
I think I told you, sir, using this filter you need to do. Filter option I have used here. For wealthy, I have selected yes in the graduation level. Once I will click on this, I will select now no, and I can press OK. I would be able to see total count is coming as 5. Wealthy people, those who are not graduated, they are 5 in number.
This is given table, na, madam. Data is already given table.
Data
na?
is given to you, but calculation I did.
Yes. Thank you. Thank you.
Okay, sir. So I hope this is clear how to calculate this contingency table is clear to everyone. May I proceed now?
Yes, ma'am.
Now you can see for calculating the p-value, same function we will use, that is chi-square.test. So you can see the function is chi-square.test, and then you need to select the observed frequencies from the first table, only the observed frequency, and do not need to include these totals. Put a comma and select this expected count range, and then close the bracket and press enter. This will give you the p-value, right? Clear to all?
Yes, ma'am.
Now we can compare this p-value with the level of significance. Suppose it is 5%. So we can compare this. So we can say that the p-value is greater than 0.05. In that case, we are going to accept the null hypothesis, right? And null hypothesis will be what? I think it is already written. You can see there is no association between the level of wealthiness and the status of graduation, right? So that way you can say this thing, that the level of wealthiness is independent of graduation. There is nothing, or there is nothing to do with the graduation, or with, and there is nothing, means the graduation is not playing the important role. This way we can see. Fine. Everyone, is it fine?
Yes.
Hello, I'm not getting clearly. Is it okay?
Yes, ma'am.
Okay, fine.
Yes.
Okay, fine. So I think this is the independence of attributes or association under the chi-square test. Two sheets I am providing you. First is for the GOF, goodness of it. Second is for the independence of attributes. So I expect everyone to perform the practice sheets so that you can understand what I have discussed today in the class, right? So this is all from my side for the day. Now the platform is open for all of you to ask me the questions.
Ma'am,
Yes.
when testing the hypothesis, we have at 0.01 level of significance also, right?
It can be anything, ma'am, depending upon your
So
assumption.
if it is at 0.01 level of significance, then the hypothesis will be rejected or accepted then.
That is, ma'am, depending. After asking question, please mute yourself.
Okay, sure.
Yeah, sorry, because it is echoing. I cannot listen my voice properly. Sorry. Okay, give me a second. See, it is nothing to say with your level of significance, ma'am. It can be anything. Decision will not change. You need to see only here the p-value is this, right? Now, instead of 5%, you want to put the level of significance as 1%, right? So I can say 1% means 0.01, right? So you need to compare your p-value with 0.01. So you can compare this. And after comparison also we can say that this p-value is greater than your level of significance. So that means again you are going to accept the null hypothesis. So the ultimate purpose is that means you can say, rather than writing this, you can write this as LOS. Whatever is your LOS, accordingly you can take the decision. Fine.
Yes.
Madam, do we consider p-value along with critical and calculated value, or just p-value is enough?
Either is okay, sir. No issues. You can go with P, or either you
Okay.
can go with calculated and critical. There is no restriction in that. But if you are using software, generally suggestive is we should go with the P.
Okay.
Ma'am, sorry, excuse me. I may be slowing down in getting the point. What is this LOS, ma'am? If you
Level of significance.
Okay, sorry. Thank
No problem. It's totally fine.
Good evening, ma'am.
Good
Ma'am,
evening.
sometime it happened that our p value is not significant with the the traditional value, but the R square is good. So in that situation, how can we handle the data? Can you please suggest me some
In
points?
which particular case you are talking about, sir?
Like I'm regretting on my data, So my R square is good, but the p value is not significant with the level of significance. So can you suggest me some
Are you talking about regression or something?
regression? Yes, ma'am.
So, sir, I think I'm going to discuss regression afterwards. In that case, I'll cover this.
Okay, ma'am. Okay. And one more question: do you already provided the Excel sheet, or you will provide?
I think it is shared by me on the WhatsApp group, sir. It is available there.
Okay.
Yeah. So, anything else?
Ma'am, can I get the recording of this class? Where can I get?
I think it is available on the RFI channel, or otherwise you can follow me on YouTube also with the name Dr. Chanchal Jain. On YouTube
Ma'am,
also
it's
you can find some
available.
of my videos.
We have already shared the YouTube link there. It is a recorded lecture. You can go through that.
Okay, ma'am. Thank you.
Ma'am, this chi-square test, I think, what about in qualitative research method, this chi-square test?
Ma'am, it is for the numeric data. Sorry, it is generally for the categories only, because we are dealing with the categorical data here. So if you are having categorical data, the form I have shown you, as I said, whether I'm liking this, yes or no, I'm saying. Whether I'm liking the statistics, I said yes, or someone says no. So this is categorical. This is the qualitative data only, and I have counted how many of the people are saying yes and how many of the people are saying no. So such kind of a scale, if you are using, in that case, you can apply chi-square.
Okay, thank you so much, ma'am.
Okay, so I think this is all. Anything else you are having? No
Shall we,
doubt.
shall we conclude the session, ma'am, now?
Ma'am, I think yes, but I don't know how many of them are okay.
Ma'am, okay, we can conclude.
Okay.
Thank you so much. Thank you so much, ma'am, for this
Very good. Thank
thoughtful
you.
Thank you,
and
madam.
relevant session, ma'am. We have enjoyed every second of the session. And thank you so much to all the participants also for being a patient and good listener and being a more participative in this session. Thank you, ma'am. Thank you, all the participants. Have a good day, everyone.
Thank you so much.
Thank you, ma'am. Thank you.
Can we take a
Thank
pic?
you, ma'am. Thank you
Is it
so
possible
much.
to capture a pic? Can you people switch on your cameras?
Sure, ma'am.
Yeah.
Sure, ma'am.
Yeah.
Yes, ma'am.
Okay, great. Very good. I can see few of you to whom I was interacting since last 1.5 hours. Yeah. Thank you so much, everyone.
Thank you.
See
Thank you, ma'am.
See you tomorrow.
Thank
Yeah.
you, ma'am.
Good night. Take care, everyone. Bye. Nikita, ma'am, may I leave the meeting now?
Madam, is there any feedback link?
It will be provided you, sir, on the last day of the session.
Okay, ma'am. Thank you.